In this video, you are going to learn what is the Stackable Planetary Gearbox, how it works, application of the Stackable Planetary Gearbox, and advantages and disadvantages of Stackable Planetary Gearbox. Stackable Planetary Gearbox is an assembly of a number of stacks of the planetary gearbox. It can have an unlimited number of stages, but the practical limit is 3 stages. The assembly you will see in this video has 2 stages of the planetary gearbox. The 3 parts divide a stage across a planetary gearbox. We can offer double or triple stages for greater ratios. A planetary gearbox is an instrument with the output and input shafts aligned. A planetary gearbox is employed to transmit the greatest torque in the most compact form, introduced as the torque density. A simple planetary gear set is constructed of 4 basic parts. The sun gear is located in the center, several planet gears, the ring gear, and the carrier. The planetary gearbox got its term because of how the various gears move in a set together. The sun gear is normally run and thus move the planet gears bolted in the planet carrier and form the output shaft. The satellite gears have a constant location in relation to the outside components. This looks like our planetary solar arrangement, and that is where the term comes from. As discussed before, there is a sun gear in the middle of the planetary gearbox, also introduced as a central gear. This is always the input part. Around the outside there are 2 or more planet components or outer gears. Surrounding the planet parts, there is a ring component that combines the formation. The planet gears are joined by a carrier which in turn is attached to the output shaft. In a planetary gearbox, many teeth operate simultaneously, which provides a high-speed reduction to be obtained with comparatively small gears and lower inertia reflected back to the system. Having several teeth share the load also permits planetary parts to transfer high levels of torque. To design a proper working planetary gearbox, there is 2 conditions among the gears tooth that must be satisfied. Consider the sun gear with S teeth, planet gear with the P teeth, and ring gear with R teeth. Condition 1 is R is equal to S plus 2 times P, and condition 2 is S plus R upon N is equal to integer, where N is the number of the planet gears. By changing the input speed and locking or unlocking the carrier, you can get 4 different types of outputs. Case 1. Ring gear is fixed. When the carrier rotates around itself, planet gear will have 2 transmissions rotate around itself and the central axis of the carrier. Sun gear as input and carrier as an output, the transmission ratio will be I is equal to 1 plus R upon S. Now changing the input as a carrier and output as a sun gear, transmission ratio will be I is equal to 1 upon 1 plus R upon S. In the present case, we can obtain a reduced rotational speed. Case 2. The carrier is fixed and planet gears rotate around their axis. Sun gear is input power. Sun gear and planet gears are external gears with each other and therefore rotation transmission is reverse. Whereas ring gear and planet gear are internal gears with each other and therefore rotation transmission is the same. Sun gear as an input and ring gear as an output, transmission ratio can be calculated as minus R upon S. As ring gear input and sun gear as an output, transmission ratio I is equal to minus S upon R. Case 3. Sun gear is fixed. When the carrier rotates around itself, planet gear will have 2 transmissions, rotate around itself and a central axis of the carrier. Ring gear rotates itself around the planet gear. Here carrier is an input and ring gear as an output. Transmission ratio I is equal to 1 upon 1 plus S upon R. And for the same input but the sun gear as an output, transmission ratio can be calculated as 1 plus S upon R. The rotational speed is decreased by the planetary gearbox in this type of case. Case 4. Direct drive. A planetary gear can also be used as a so-called direct drive. The carrier and the sun gear are firmly fixed to the ring gear. In this case, the rotary motion is transmitted directly from the input shaft to the output shaft, and that's why transmission ratio will be 1:1. Such a direct drive is used, for example, in 3-speed gear hubs as the second gear. Now we think again about the case 1 where ring gear is stationary and see what happens to the planet gears. At point A, planet gear should have certain speed, and at point B, the speed should be 0 as the ring gear is stationary. Let's see how these both conditions are possible at the same time. There is only one way. The planet gear should spin as well as turn. The spinning will produce velocities in opposite direction at the top and bottom points as shown, whereas the turning produces unidirectional velocities. At the top, the spinning and turning velocities are in opposite directions, so the velocity of the point B is 0. At the bottom, they get added up. In short, the planet gear are forced to turn in order to satisfy the condition of velocity. As the carrier is attached to the planet gear, it will turn along the planet gears. A stackable planetary gearbox is generally used for the high torque transmission. For example, driving rotary and linear actuators, packaging machines, material handling systems, plasma cutting systems, industry conveyor systems, and industrial printing machines. Planetary gear offers greater efficiency, and thanks to its design and internal layout, losses are minimized during their work. Its greater speed, radial and axial load offer reliability and robustness, minimizing the misalignment of the gear. In addition, uniform transmission and low vibrations at different loads provide perfect repeatability. It gives greater stability with compact size. Planetary gearbox provides high torque density and cost-effective precision. The major drawback of the stackable planetary gearbox is high bearing load can lead to early wear in dead stud or sleeve bearing construction. Moreover, designing and manufacturing of the planetary gear system are quite complex, and the operation are noisier. Also, gearing has to be accurate, and lubrication is mandatory for smooth operations. If you want to know more about the topic, here are the literatures to get help.